Hello all. In the last video, I had covered the topic related to TJ and DTA. In this, I'll be covering differential scaling calorimetry. So basically, उन दोनों में इसमें क्या difference है मतलब this is only if you take TJ and DSC, it's completely different. TJ में आपको chemical changes के बारे में पता चलेगा, इसमें सिर्फ physical changes. DTA और DSC almost more or less same है, पर उसमें डिफरेंस इन टेम्परेचर लिया जाएगा. यहाँ पर क्या होगा मतलब रेफरेंस से सैंपल का कितना टेम्परेचर डिफरेंस है और उसे इंक्रीज करने में कितना एनर्जी चाहिए, मतलब एनर्जी एब्जॉर्ब करेगा क्या, एनर्जी रिलीज करेगा क्या, ये पता चलता है. दिस इज अ टिपिकल डायग्राम, फ्लो डायग्राम ऑफ डिफरेंशियल स्कैनिंग कैलोरीमेट्री. इसके ज़रूरत नहीं है बट आई पुट इट फॉर द कन्वीनियंस. So if you have an exothermic, you will get a peak this way, whereas if it is endothermic, it will be exactly reverse with the peak on the below the baseline. So okay, first I'll go with the definition. What is a calorimetry? Calorimetry is an instrument that you use to measure heat going out or coming into the substance, whereas differential it is related to to a reference. Differential scanning is about all these two factors and how the heating of the sample takes place with linear increase in temperature. So as we all know, endo refers to heat absorbed or heat taken into, और exo मतलब heat जो बाहर दिया जाता है. So these are the definitions of calorimetry, differential calorimetry, differential scaling calorimetry, endothermic and exothermic. So DSC is a technique. What is the principle and how does it work? Simple. In DSC आपको टेम्परेचर और हीट फ्लो के बारे में पता चलता है, इसमें which involves in transitions like change of structure, change of crystallization, then that is respect to melting point and all those factors. So it is given in the function of time and temperature in control atmosphere. Here your atmosphere is constantly inert and there will be no changes. In case of TGA, there are some cases where you can change the temperature from like from nitrogen to air, पर इसमें ऐसा नहीं होता है. It's only a constant temperature. Here you can get qualitative and quantitative information of physical and chemical changes both. पहले था एंडोथर्मिक, एक्सोथर्मिक और चेंज इन हीट कैपेसिटी. पिछले मैं टीजे के बारे में डीटीए के बारे में बता रहा था तो मैंने चेंज ऑफ हीट कैपेसिटी का बताया था, बिकॉज इफ द बेस लाइन इज स्लाइटली अबव देन एक्सपेक्टेड देन देयर इज अ चेंज इन हीट कैपेसिटी. एक्सो एंडो तो ऊपर, इफ इट कर्व कम्स बिलो इट्स एंडो, इफ इट गोस अबव इट्स एक्सो, ऐसा बोला था. सो नाउ नेक्स्ट इज व्हाट वी कैन मेजर इन डीएससी. DSC it's a fingerprint of minerals, layer polymer, because each has a unique, like for NMRs we say it is unique. Similarly, DSC curve of each mineral layer polymer is unique. So the melting point means the sample purity. If sample is highly pure, the melting point will be constant, matching what we have got. Otherwise we can see there is impurity. Heat capacity, CP. What is heat difference? Then glass transition temperature, more dealing with polymers. Crystalline, this is for crystals and some cases polymers. And with this also you can draw the phase diagram about what temperature it melts, comes to liquid or goes to gaseous form. We can find out. So this is a typical DSC curve for thermosetting polymer. Thermosetting. See here, initially we have glass transition temperature here. This is extent of crystallization. Here it's melting. This is cross linking or also called curling, and this is oxidation. Glass temperature मतलब at the temperature where rather than polymer it acts like a glass. Crystallization means here it undergoes crystallization, and at higher temperature it starts melting. So here if you consider this as the baseline, here there is a change in CP, and if you take this is exothermic. Here again it's endothermic, same, this is exo, and again here since it is going up and there is no coming down, it's exo. So this is a typical curve, how it comes. Now the major difference with TGA, DTA or DSC, this is more or less same, and it is a TGA, it only refers to change in weight. मतलब वेट टेम्परेचर के हिसाब से वेट को क्या सैंपल के वेट से क्या डिफरेंस है. बट इन केस ऑफ DTA DSC योर वेट विल बी इमटेरियल. कितना वेट डिफरेंस हुआ है कुछ भी नहीं रहेगा. ओनली वेदर व्हाट फेज चेंज, वेदर हीट एब्जॉर्ब हुआ है, हीट रिड्यूस, हीट रिलीज हुआ है, या फेज क्या CP में क्या हीट कैपेसिटी में कितना डिफरेंस है वो पता चलेगा. बट इट डज नॉट हैव एनी कंसर्न विद योर वेट्स. This is a thermogram containing TGA, DTA and DSC curves. So now a brief about phase transition. This part is actually not required, but I'm giving it as for extra information. So first order phase transition, whereas derivatives are not equal. First derivative, second derivative, thermodynamic potential by temperature is not zero. That is delta G by delta T constant pressure is equal to minus delta S, which is not equal to zero. Similarly, dou square delta G by dou T square is also not equal to zero, where the pressure is constant. In this case, we will get crystallization melting, or melting point we can consider. In case of second order transitions, the first derivative of thermodynamic potential by temperature is zero, and second derivative not zero. So though d difference in Gibbs free energy by temperature at constant pressure minus S, which is he said is equal to zero, but in this case it is not equal to zero. What is the example is ferromagnetic and diamagnetic transitions. So this is actually not required, but this is for extra information they clear, because in case they may ask, extreme rare case they may ask what is this first order transition, second order transition. So application, general applications, polymer characterization, then we can polymer characterization I showed you कैसे curves आ जाते हैं, what is this. There they are not shown the temperature, but if you take the temperature we can calculate about what temperature, what is the glass transition temperature, कितने temperature से crystallization start होता है, what is the melting point range, then what temperature is going to go cross linking, then at what temperature it will oxidize, is there any change in its heat capacity and all those stuff. Gas absorption, यहाँ पर say if you heat it will start desorption, means it will start releasing out the hydrogen gas. This study also can be done. So it's like cyclic. See here it's getting heated, यहाँ से आ जाएगा up till here, later it starts cooling it. So you will get the near similar curve of what we have got for on heating. Desorption, absorption will be there, but here there will be slightly distinct peaks. So with this I like to end. So in the next video you will be understanding how to understand the curves, what is the working of the curves, that will be explaining. In the last video I'll be in the fourth and the last video I'll be dealing with different numericals and questions which have come in the previous GATE, NET and SET. Please do like, subscribe and follow my channel for more updates.